An actuary determines the following regarding an individual auto policyholder. The probability that the policyholder will file medical claim is 0.3, property claim is 0.42, and probability of medical claim or property claim is 0.6. Find the probability that the holder will file exactly one type of claim given that the holder will not file both types of claims. So let the medical claim be X. X be the event of filing a medical claim, Y be the event of filing a property claim. Then we are given that P of X is 0.3, P of Y is 0.42. And since we are given that property or medical claim probability is 0.6, and we know that OR means union, so that's probability of X union Y, that's 0.6. By addition rule, P of X union Y equals PX plus PY minus P of XY. And this gives us P of xy equals 0.12. Now, P of xy means X, probability of X and Y, which means probability of filing both the claims. And the last part of the problem, the given condition is that he does not file both the claims. So let be the event that the holder will not file both the claims. So if we look back, we are given that the policyholder will not file both types of claims. So since probability of both claims is 0.12, so not both claims would be the complement of that. So therefore, if n is the event of not filing both types of claims, then P of n would be 0.88. And we are to find the probability of filing exactly one type of claim given of not filing both types of claims. So exactly one given not both would be exactly one and not both by our basic formula divided by probability not both. And if we look at the numerator, we are saying a redundant thing when we say exactly one and not both, because exactly one obviously means that you're not filing both. So this can be compressed to just exactly one. So therefore, we have probability of exactly one divided by probability of not both, which is P of n. And now exactly one is filed if you either file the medical claim and not the property claim, or the property claim and not the medical claim. So that's equal to P of X and not Y plus probability of Y and not X. We know OR means addition. So now we also need the partition rule. And the partition rule in its basic form, as is given in the formula sheet, is P of A equals P of AB plus P of AB complement. And from here, we can find that P of AB complement is equal to PA minus PAB. Now, AB complement can also be read as A and not B. And AB, it means A and B. So using that fact, we see that probability of, so partition rule will say X and not Y equals P of X minus P of XY, or X and Y. And P of X is 0.3. P of XY we found out just from the addition rule was 0.12. And so 0.3 minus 0.12 is 0.18. And similarly, invoking the partition rule again, and this time on y and not x, so that would be P of y minus P of yx. So that would be 0.42. P of y was 0.42, and P of yx is the same as P of xy, which we found above to be 0.12 here. And so P of y and not x comes out to be 0.42 minus 0.12 equals 0.3. So equation 2 then becomes exactly 1 is equal to 0.18 plus 0.3, that's 0.48. And now substituting this in equation 1, so the exactly 1 was the numerator, so the numerator would be 0.48, the denominator of was Pn, which we found to be 0.88. So the required probability would be 0.48 divided by 0.88, and that is 0.55. That is choice D.